Number one, the students investigate the variations with temperature theta of the resistance R of a copper wire. The plastic-covered copper wire is wrapped around a mercury in glass thermometer and immersed in a beaker of water. The students allow the water to cool slowly from 95 degrees Celsius. The students measure the resistance of the wire and the temperature of the water at the same instant. Their results are shown with error bars. For R, errors in theta can be ignored. Question A, the student suggests that R is given by this equation. Draw a line of best fit for this data that is consistent with this equation. The line you can create like this. From this initial point to the last point. Wow. Next question. Calculate the gradient of your best fit line. So the gradient we can calculate through this point, this coordinate point. This coordinate point, so becomes like this. Okay. This distance divided by. Okay. So we are going to find this coordinate point. This is around 7.9. Okay, and then minus around this is 6.3. Okay, this one, and it means 7.9 minus 6.3 divided by, now from this point to this point is around 96, around 96 here, 96 to here is 21, so 96 actually here, and this is 21. So 96 minus 21. We'll calculate here. So M equal 7.9 minus 6.3 divided by 96 minus 21. And if you calculate, the result is 0.02133, so on. And this use alpha, state an appropriate unit for alpha, according to the information that the formula of gradient is the alpha times R0. This is gradients. Okay. So it means alpha equal gradient divided by R0 or initial R. So it's going, if R0 equal 6.3 ohms, if you look on this diagram, okay, alpha is 6.3. So 6.3 here, that R0, 6.3 ohms. So we can calculate alpha through this formula. Gradient is 0.02133 divided by 6.3 ohms, and it's equal 0.0033862 degrees Celsius power minus 1. This is the unit. The unit, based on this question, the unit is 1. C power minus 1. Next question, number 2. A small ball is released from rest at time t equals 0 in front of a vertical ruler. A multi-flash photograph is taken of the ball at t equals 0 and every 0.050 second from then on. This is the ruler. Question. The distance as fallen by the ball is related to the acceleration g of the ball and t by s equal 1/2 gt squared. That means g using the photograph. So if you look the photograph, the ruler, the photograph, when t equals 0 second, the ball position, the ball positions at 5 centimeters. Okay, this. When t equals 0, the ball position at 5 centimeters, and when t equals 0.05, because of every according to this information 0.050, the ball position at 6.2 centimeters. So when t equal 0.050 second, the ball position at 6.2 centimeters. So the distance or s equal 1.2 centimeters because 6.2 minus 5. So now we are going to, based on this formula, if G is the subject, we can rearrange this formula. It's going to be G equal 2S divided by T squared. Okay. This is the formula of G. So we can calculate G, just substitute this information, 2 times S equal 1.2 divided by T equals 1, 0.050 second squared. And if you calculate, the result is centimeters. If you calculate, the result is 960 centimeters squared, centimeter per second squared. So this is the answer, the G. Next question. The percentage uncertainty in T is plus minus 5%. Estimate the absolute uncertainty in your value of G. Right. From part A, we got formula that G equal to S over T squared. The uncertainty in G depends on the uncertainty in T as well. So we can use the formula for the uncertainty propagations like, so the formula delta G divided by G equal to delta T over T, right? So delta G over G equal 2 times 0.05. This is 0.05 because of this 5%. So it means delta G over G, it is 0.10. Next, delta G from this equation, it means delta G equals 0.10 times G. Hold on first, and it becomes 0.10 times 960. So it's going to be 96 centimeters. Second power minus 2. So the value of G with its uncertainty is 960 plus minus 96 from the delta G. Okay. So the unit. So, next question. Suggest a suitable value for the maximum durations of the flash. We want the ball travel a distance no greater than the uncertainty in position during the flash. So we can determine the maximum flash duration through the formula that delta S equal, sorry, my cell phone thingy, delta S equal uh, V times delta T maximum. So it means delta T maximum equal delta S over V, one. And then uncertainty in positions, delta S equal, delta S equals 1 millimeters. So it's going to be 1 millimeters divided by 2 meter per second. So delta T maximum equals 0.001 meters. We need to convert to meter because this is the unit is meter per second. So by 2 meter per second. And the result is 0.0005 millisecond. Yeah, this one. Sorry, second, I mean, 0.05 second, and it's going to be 0.5 milliseconds, one. Or 1 over 2000 second. So 1 over 2000 second, same with 0.5 millisecond. And next question, number 3. P transmits a radio signal to Q relative to the Earth's surface. Q is stationary and P moves at a speed of 0.70 c as shown. One. State using Galilean relativity the speed of the radio signal relative to Q. Okay, so we can determine the speed using the Galilean velocity addition formula. It says that V signal relative Q, V signal relative Q, okay, the signal relative Q equal V signal relative of P plus VP. VP is the speed of P relative to Q. Okay, C is the speed of radio signal relative to P. And then substitute the number is going to be C plus 0.70 C. So P signal relative to P is C and Vp is 0.70 C based on this information. And the result is 1.70 C. One. Next question. Determine using relativistic velocity addition the speed of the radio signal relative to Q. So we need to using the relativistic velocity addition formula that U equal U accent plus V over 1 plus U accent V over C squared. And it is C plus 0.70 C over 1 plus C times 0.70 C over C squared. It is 1.70 C over 1 plus 0.70 C. It is 1.70 C over 1 sorry, this is C squared over C squared, okay, 1.70. So the result is C. Then a paradigm shift in science replaced Galilean relativity with the theory of special relativity. Explain how this paradigm shift was linked to Maxwell's discovery of a set of electromagnetic equations. I have answer this one. This is my answer. Next question, number 4. The space-time diagram X, CT for a space station S shows the world lines of two clocks, clock 1 and clock 2. Each clock is 2 kilometers from S. The space-time diagram also shows the world line of spaceship A. This is the diagram. And this is the line of spaceship A. Question. Outline how clock 1 and clock 2 can be synchronized with the clock on S. I have provided my answer for this question one. Let's continue to the next question. Determine in terms of C the speed of A in the reference frame of S. Okay. If you look at the diagram, this angle is angle theta. Okay. And this this is X. Based on this information, this is the x-axis. So it means the tangent, writing here. Okay, the tangent theta based on the diagram just now I show you, tangent theta equal 2 over 8. It is 1/4. Also, tangent theta we can state as x over ct. Okay, x-axis over ct axis. And you know that ct equals c times t. Okay, so it means t equal ct over c, like this. And the speed or velocity equal x over t. Okay, so x over, based on this information, this equation, ct over c, or x over ct times c. And x over ct is this one, tangent theta. So it is tangent theta times c. Tangent theta is 1/4. So the velocity or speed is 1/4 c. Next question. Clock 1 and clock 2 emit separate light signals when A is at origin 0, 0, and identify on the diagram the proper time that elapses between the arrival of the light signals at A. Okay. I would like to clean first one. If you look at the diagram, clock one is at +2 and clock 2 is at -2. So it means at x equal 2 kilometers and x equal -2 kilometers. Position at time t is the formula I'm going to write in here. The speed formula x xt or vt, I would like to use in vt, equal 1/4 ct. So when t equal 8, and so when t equal 8, when t equal 8, so the v8 equal 1/4 c times 8. Okay, so it means it is 2c, because 8 times 1/4. 2c it means here. So I would like to see here. So this is the axis of CT. Okay, so I would like to create a straight line from origin, from here -2 to this this point. Okay, okay, and after that from this, from two, okay, from two, two to this point. Okay, so this is okay, okay. This is the proper time. This one on this diagram. So the proper time on this one. Okay, let's continue. Next question. Oh, sorry, B first. And even E space space P leaves S to intercept spaceship A. The speed of P is 0.50 c in the reference frame of S. Identify with the letter X on the diagram the event of P intercepting A. Okay, so I will go and show you through this diagram. Okay, according to the information that Vp equal, okay, Vp equal 0.50 c. So it means the gradient is one 0.50. So equal tangent theta p of spaceship p is ct for x. It is c over vp or velocity of p is one or c over 0.050 c. So it means it is the tangent theta equal 2 because 1 over 0.05. It means the gradient or m equal 2. So x equal 2. If x equal 2, well, x equal 2, and x equal 2, based on this information as well, it can determine ct. Ct equal 4 because gradient is ct over x. Okay, ct over x. So maybe some of you confused. So gradient m equals ct over x, or 2 equal ct over 2. So ct equal 4. If ct equal 4, we can determine ct4 from this point. This is 2. Okay, and it means 4 from this coordinate point to upwards is here. So x point is here, and the spaceship P through x here. Think clear? Next question. Sorry. State in seconds the time of event X for clock 2. Okay. So 8 kilometers equal 8,000 meters. So T equal S over C. So it means 8,000 meters over 3 times 10 power 8 meter per second. This is speed of light, 3 times 10 power 8. So if you calculate this result, the result is 2.7 times 10 power minus 5 second. Next question. C, spaceship A then returns to S. The space-time diagram shows the rest frame of A on its outward journey, x-axis, city-axis, and on its return journey, x-double-axis, city-double-axis. An observer in A determines for the reference frame of S the time t1 immediately before the change of velocity of A and the time t2 immediately after the change of velocity of A. Identify with lines and labels on the space-time diagram the difference between t1 and t2. So T1 first. T1 is parallel with x-axis, so it's going to be like this. It's parallel. Okay, this is T1. Meanwhile, T2 parallel with x w axis. Okay, this is T2. And the difference is delta T. It's a delta T. Okay. Explain how the difference between T1 and T2 arises. I have provided my explanation about this question. Let's continue. Muons are formed in the Earth's atmosphere 2.5 kilometers above the surface and then travel vertically downwards at a speed of 0.975 c. C is speed of light. The mean lifetime of a muon is 2.2 microsecond or musecond when measured in a frame in which the muon is at rest. Calculate the mean lifetime of the muon for the reference frame of the Earth. I will use the formula for time dilation, and the formula is delta t xn equal delta t over square root 1 minus v squared over c squared. Delta t is 1, 2.2 second over 1 minus v is 1 minus 0.975 c squared over c squared. C squared divided by c squared equal 1. So it's going to be 2.2 second over square root 1 minus 0.975 squared. And the result is 2.2 second over 0.049375. And if you calculate, the result is 9.91 second. Let's continue. Muons are detected at the Earth's surface. Explain with supporting calculations why this is evidence for time dilation. Okay, so to calculate the time taken to reach Earth as measured in the Earth frame, we need to find time first. T equal d over v. D is a distance. Based on the information that the distance equal 2.5 kilometers, I will convert becomes meters, so 2,500 meters. It is 2,500 meters over the velocity 0.975 c, but c I would like to write it as speed of light 3 times 10 power 8, and it is 8.5 times 10 power minus 6 s, or 8.5 second. Okay. Now we're gonna find the time dilation. the action. The action equal gamma times torque, okay, 0. It is becomes this is 2.2 mu s, 2.2 mu s, while this one is 1 over square root 1 minus p squared c squared. It means 0.975 squared. Just now we calculate already this one. So it's going to be 2.2 over square root 0.0494 becomes 2.2 over 0.222 on, and it is 9.9 mu s. And for the explanation, I have provided this one here. Let's continue. The graph shows the variations of kinetic energy with gamma factor for a muon. This is the graph. Calculate the rest energy of the muon. To calculate the rest energy of the muon using graph, we use the formula kinetic energy equal gamma minus 1 times m0c squared. Okay. And after that, I would like to rearrange this formula becomes, because we need to find this result, m0c squared equal kinetic energy over gamma minus 1, right? And we are going to using this coordinate point, this coordinate point. This is 5 and 425. So it means gamma is 5 and kinetic energy based on this information that kinetic energy, the unit is mega electron volt, 425 mega electron volt. So this calculation becomes 425 over 5 minus 1. So becomes 106.25 mega electron volt or 106 mega electron volt. Next question. The muon has the same charge as an electron. Deduce the potential difference required to accelerate a muon from rest to a speed of 0.96 c. C is light of speed. Okay. From the Lorentz factor formula, I will use the formula that gamma equal 1 over just now from this part. Yeah, from part 5 for question 5, actually gamma equal this one here, gamma equal 1 over square root 1 minus v squared c squared. On part 5 we already using this formula, so this is 1 square root 1 over v squared over c squared. So 1 over square root 1 minus 0.96c over c squared. This is c squared. Okay. So it's going to be 1 over square root of 1 minus 1 minus 0.9926, sorry, 9216, sorry, 16, okay, squared this. And if you calculate, the result is 1 over 2 8, and it is 3.6. This is for gamma, and the relativistic kinetic energy is here, K equal gamma minus 1 and 0 c squared, and it is 3.6 minus 1 times 106, 275 times 6. Sorry, this is the result. And then it's going to be here, and I would like to writing here, the result is 275.6 megaelectron volt. So we are going to convert mega electron volt becomes this is, yeah, kinetic energy. We are going to convert to potential difference or volt, and volt becomes EK over E, 275 mega electron volt becomes divided by E, divided by E. So this is 275 MV, mega volt. So what? Next question, number 7. A distant observer observes a spacecraft that is falling freely towards a black hole. According to an observer in the spacecraft, a light ray enters an observation window out the spacecraft and leaves through a second window directly opposite the first. This is a diagram. Explain the difference between the path of the light ray as described by the distant observer and the path of the light ray as described by the observer in the spacecraft. I have provided my answer about this question. Okay. Let's continue to the next question. The event horizon is 300 kilometers from the center of the black hole. When the spacecraft is at 100 kilometers from the event horizon of the black hole, it transmits a radio signal to the distant observer. The duration of the radio message, according to the observer on the spacecraft, is 7.5 millisecond or millisecond. Calculate the duration of the radio message as received by the distant observer. I will, in this case, this is the case of a gravitational time dilation near a Schwarzschild black hole. So I will use the formula delta T equal delta R over the root 1 minus Rs over R. So this is 7.5 mu s. Okay. Based on this information, 1 minus 300 per 400, because 300 plus 100. Okay. 7.5 over square root 1 minus 0.75, because this is actually 3/4. So 7.5 over 0.5, because this is square root of 0.25. And the result is, if you calculate 15 mu second or 15 millisecond. Next question. Calculate the mass of the black hole. We're using a formula derived from the Schwarzschild radius. The Schwarzschild radius formula is Rs equal to Gm over c squared. This is m. So it means we're going to find mass. Mass equal Rs times c squared over 2g. So m equal 3.00 times 10 power 5 times 3.00 times 10 power 8 squared. Okay, and this is 3.00. And then divided by 2g, it means 2 times 6.674 times 10 power minus 11. And if you calculate this is 2.70 10 to the power 22 over 1.3348 times 10 to the power minus 10. And the result is 2.02 times 10 power 32 kilograms. This is the mass of black hole. Next question, number 8. A flywheel is a rotating cylinder used to store rotational kinetic energy. The energy can be transferred from the flywheel as it slows down. So this flywheel more and more will decrease and it slows down and will be stopped. A flywheel used to store energy has a moment of inertia 0.072 kilograms per meter squared and a maximum angular speed of 8,400 radian per second. Question. The rotational speed of flywheel is reduced uniformly from the maximum speed to 3,600 radian per second in a time of 9.6 seconds. Show that an average power of about 200 kilowatts is transferred from the flywheel as its speed is reduced. So I'm going to using change in rotational kinetic energy. So delta E equal 1/2 times I times initial angular speed. This is omega I. It means the initial angular speed minus the final angular speed squared. So it's going to be 1/2 times 0.072 times 8,400 squared minus 3,600 squared here inside. And the result is 2 million, sorry, 2,073,600 joule. Okay. So the answer that the average power. So the average power, the average power, I'm going to use in P. Okay. Okay. P equal delta E over delta T. Change in E, change change in T, change in this one, this energy. So it's going to be 2,073,600 joule over delta T is 9.6 based on this information. And the result is 216,000 watts. Now convert to kilowatts becomes 216 kilowatts. Right. And next question, calculate the torque acting on the flywheel as it decelerates. Right. To calculate the torque acting on the flywheel during deceleration, we can use the relationship between power, torque, and the angular speed. The formula is P equal tau times omega. If we are going to find torque, tau is torque equal power over omega. This is omega, not W. And we need to find the omega average first. Okay. Omega average equal omega I plus omega F, the initial plus final divided by 2. It is 8,400 plus 3,600 divided by 2. And it is 6,000 radian per second. Next, we're going to find torque. Okay. Torque equal 2.16 times 10 to the power 5 over 6,000. And the result is 36 Newton meters. Next question. Calculate the number of revolutions that the flywheel makes as it slows down. Okay, so I'm going to using this formula that theta equal omega average. Just now we calculate, okay, and it is 6,000 times 9.6 equal 57,600 radians. Now we are going to convert radians to revolution. So number of revolution revolutions equal theta over 2 pi. 57,600 over 6.2832, and the result is 9,170 revolution. Okay. Next question, B. An engineer changes the flywheel design to increase the maximum energy that it can store. Identify two factors that the engineer can change to do this. I have provided my answer. This one. Okay. Let's continue to the next question. Number 9. A fixed mass of an ideal gas is taken through a cycle that consists of 3 processes. X2Y isothermal compression from a pressure of 0.10 megapascal and volume of 1.20 times 10 power minus 3 m cubed to a pressure of 0.48 MPa and Pascal. ISO Y to Z isobaric expansion, X to Z to X adiabatic expansion to the initial state. Draw on the axis the pressure V volume diagram for this cycle X and Y are plotted for you. Numbers are not required on the axis. Okay. Right. First from X to Y, isothermal compressions. Isothermal compressions means the curve inward, like this, from X to Y. X to Y like this, okay? The curve inward, the direction to from X to Y. And after that, Y to Z is isobaric expansions. If you see here, Okay. Isobaric expansion, it means horizontal line, okay, y to z, and then C2x, according to this information, adiabatic expansion to the initial state. It returns to x. So it means the curve, steeper curve downward, steeper curve downward. Yeah. Okay. Next question. Show that the volume of the gas at y is 0.25 times 10 power minus 3 m cubed. For an isothermal process, the ideal gas law, okay, at y, it gives Px, Vx, P pressure, V volume, equal Py times Vy. We are going to find Vy, so we need to set this equation, this formula, which Vy is the subject. So it's going to be Px, Vx over Py. Becomes 1.0 times 10 power 5 times 1.20 times 10 to the power minus 3 over 4.8 times 10 to the power 5. So divided becomes 1. And if you calculate, the result is 0.25 times 10 power minus 3 m cubed. Next question. An algebraic statement of the first law of thermodynamics is Q equal delta U plus W. Data for the cycle are provided in this table. Complete the table, use the answer box below for your calculation. Right. I would like to start from this process, x to y. Work, okay, work is minus 188, 188. Okay. Okay. Process x to y. So work equal minus 188. This one. And that delta U, this one, delta U, this is isothermal, delta U is the internal energy depends on the temperature which is constant in isothermal process. So delta U, okay, delta U equal 0. It is 0 here. And so how about Q, this one? Q equal delta U plus W equals 0 plus minus 188, and it is minus 188. So minus 188 here. Now, y to z. Y to z. For y to z, that q equal, this one, q equal 262 and w equal 105. So it means delta u equal q minus w, or 262 minus 105, and the result is 157 joule. 157 joule. The unit is joule. The next process, x to z to x. Z to x. Z to x, W equal plus 157 joule, and this is a return to the original state. So it means delta U equal minus 0 plus 157. So it is minus 157. So 157 here, minus 157. Okay. And the next step is Q. Okay, Q is one. This for this column. Q is W, the delta U plus W. I mean, so minus 157 plus 157, zero. This is zero here. And the fourth is whole cycle. The whole cycle Q total, Q total is minus 188 plus 262 plus 0. Okay, is 74. This is 74. And after that, total delta U, 0 plus 157 minus 157 equal 0. Complete. Next question. Determine the volume of the gas at Z. We use the work formula for isobaric expansion Y to Z. This is isobaric expansion. So W equal P times delta phi equal P pressure times volume on C minus volume on Y. We are going to find this one, phi C, volume on Z. So it means phi C, rearrange this formula becomes W over P plus phi Y, or 105 over 4.8 times 10 to the power 5 plus 0.25 times 10 power minus 3. And it is 2.1875 times 10 power minus 4 plus 0.25 times 10 power minus 3. And the result is 4.6875. You can calculate by yourself. M cubed, or 0.47 times 10 power minus 3. Okay. M cubed. Next question. Determine the efficiency of this cycle. Efficiency. So this is the volume of volume at C. Now efficiency of a heat engine. Okay, efficiency equal work net over Q in equal efficiency equals 74 over 262 times 100%. Because efficiency in percentage, so we got the percentage is 0.2824 or 28.24% times 100%, or it is 28%. So this is the efficiency. Outline why this theoretical cycle is unsuitable for use in a practical heat engine. I have provided my brief explanation about this quiz or this question. This one. Number 10. A swimming pool consists of a large tank above ground that is being filled with water. The water flows into the tank through a pipe of radius 0.13 meters at a flow speed of 66 mm millimeter second or minus 1 millimeter per second. One. Density of water is 1000 kilogram meter per meter cube. This is rho, density of water. Viscosity of water is 1.1 times 10 power minus 3 parts per second. This one. So this is eta, the symbol. Identify whether the flow of the water in the pipe is likely to be turbulent. Okay. So I will use the Reynolds numbers formula R equal V times tau times rho, okay, over eta, and it is 6.6 times 10 power minus 2 times 0.13 times 1,000 over 1.1 times 10 power minus 3 based on this information. And if you calculate, the result is 7,800. And this result greater than 4,000. Okay, if greater than 4,000, it means we can say that R greater than 4,000. If greater than 4,000, we can conclude that the flow is turbulent. Question B. There is a small hole in the side of the tank through which water escapes. So this is the small hole. Okay. The small hole is 0.8 meters above the bottom of the tank, and the radius of the small hole is 19 millimeters. The depth of water D does not change once the flow rate into the tank is equal to the flow rate out of the tank. Determine this constant value of D. Right. So I would like to using first the equation that inflow rate equal the outflow rate. So it means Q in equal the Q out. This one, I will use this one. Where is Q in, the formula, the inflow formula is area in times volume in. It means pi r squared in times volume in. Meanwhile, the Q out equal pi r squared out times volume out. So we are going to find first this one, volume out. If Q in, based on this statement, Q in equal Q out, it means pi r squared in equal times V in first times V in equals pi r squared out times V out. So we can rearrange this formula if V out, the subject V out equal pi r squared in times V in over pi r squared out. And it is if you substitute the information, it is pi times 0.13 squared times 6.6 times 10 power minus 2 divided pi times 0.019 squared equal 1, and it's going to be 0.0169 times 6.6 times 10 power minus 2 over 0. H equals 1, 0.000361. And the result is 3.1 meter per second. And the next step, I will using the Torricelli's law. The Torricelli's law, phi equal square root 2gh. We are going to find depth. It means we need to find h. So h or depth equal phi squared over 2g equal 3.1 squared over 2 times 9.81. So it's going to be 9.61, yep, over 19.62. And if you calculate, the result is 0.49 meters. So the total depth, total water depth equals 0.49 plus 0.80. Okay. The small hole depth, it is 1.3 meters. So the answer is 1.3 meters. Next question. A block of wood floats on the surface of the water, outlined with reference to pressure, the origin of the buoyancy force on the block. I have provided my brief explanation about this question, this one. Number 11, after that, a person rides a recumbent bicycle that has a suspension unit mounted between the saddle and the bicycle frame. The suspension unit supports the mass of the person and consists of a spring with a damping mechanism. The natural frequency of vibrations, the suspension unit is this one, 2.6 hertz. Okay. This one. The suspension unit is damaged so that the spring is undamped. The bicycle travels over bumpy ground with bumps separated by equal distance of 1.2 meters. Explain why the ride is uncomfortable when the speed of the bicycle is 3.0 meters per second. Okay, so the time interval between each bumps, we are going to find time. First, time equal distance between bumps, 1.2 meters over speed, and the speed is 3.0 meter per second, and it is 0.4 second if you divide 1.2 over 3. So it means the bumps are hit every 0.4 second, which correspond to a frequency f bumps, frequency bumps equal 1 over 0.4 second, and it is 2.5 hertz. From the equation, we have information that the frequency, the F natural, is 2.6 hertz. So I have provided my answers one. Okay. Next, continue to B. The suspension unit is repaired so that the spring is jammed. Describe any change that the person will notice when riding over the same bumpy ground. I have provided also my brief explanations about this question. Number 12. A real image 4 times larger than the object. It forms 0.40 meters from a converging lens. Calculate the focal length of the lens. Okay. Uh, we use magnification when m equals 1. When m or magnification, wait, I will use when the magnification equal 4. Okay, visual information. So m equal phi over u. Okay, and it is equal 4 based on this statement. So it means u equal phi quarter, phi over 4. And we use Lenz's formula or the Mayer equation 1 over f, 1 over phi plus 1 over u. Okay, and it becomes 1 over f equal 1 over phi plus u is 1, 1 over phi over 4, like this. So it's going to be 1 over phi plus 4 over phi. So it's going to be 5 over phi. So 1 over f is equal to 1, 5 over phi. So it means we can state that f equal phi, opposite of this fraction, phi over 5, phi fifth, and its equal phi is 40, because if 40, 0.40 meters, it is 40 centimeters. So it's going to be 40 over 5. It is 8.0 centimeters. Next question. The converging lens is replaced by a diverging lens of focal length f. The positions of the object is shown like this. The question. Determine using a ray diagram the nature of the image form. We need to sketch first. If the object here, so the ray like this, going to here, and then from this focus, okay, this focal length, and after that, from this object to this F to the center, okay, to the center, okay, to F here, okay, and the image here, to the image, okay, and the nature of the image form, this one I have something it virtual upright and diminished. Next question. Identify the optical components in an astronomical reflecting telescope with Newtonian mounted telescope, Newtonian mountain. So I have provided my brief explanation, my answer for this question. Explain one advantage that an astronomical reflecting telescope with Cassegrain mounting has over one with a Newtonian mounting. So I have provided and continue. In a reflecting telescope with a Cassegrain mounting, the primary mirror has focal length of 8.0 meters. The telescope is used to view a feature on the moon that subtends an angle 2.5 milliradian at the axis of the primary mirror. Question: calculate the height of the image formed by the primary mirror. Okay, so I will using the formula H because the question is about height. The height F equal F times theta. F is 8.0 meters and theta here theta equal 2.5 milliradians. It means 2.5 times 10 power minus 3 radians. It's going to be 8.0 meters times 2.5 times 10 power minus 3 radians. And if you calculate, the result is 20 times 10 power minus 3, and it is 2.0 times 10 power minus 2. And the unit is meters. Okay. The initial paths of two rays parallel to the principal axis are shown on the diagram show by completing the paths of these rays, the information of the final image at X. Okay, we're going to continue to sketch this rays. Okay, so this rays we're going to this primary mirror. Straight line. Okay, and after that to secondary, okay, as well. So on. And reflect to here to the secondary mirror. And from secondary mirror to eyepiece here, eyepiece X eyepiece here. Okay, eyepiece. So it's going to eyepiece here. Okay. The secondary mirror is 4.5 meters from X. Calculate the focal length of the secondary mirror. Okay. So first I will find U. U is 4.5 minus 8, and it's equal minus 3.5. Okay. So we're gonna using mirror equation 1 over F, 1 over V plus 1 over U. 1 over F equal 1 over 4.5 minus, because it's minus, 1 over 3.5. So it's equal 3.5 minus 4.5 over 15.75. So it is minus 1 over 15.75. So 1 over F, okay, this is 1 over F equals 1. Minus 1 minus 1 over 15.75. So it means F is the opposite of this fraction. minus 15.75 over 1, or minus 15.8, and the unit is meters. Number 14, light propagates along an optic fiber that has a core of refractive index 1.59 and a cladding of refractive index 1.48. Show that the critical angle at the core cladding boundary is approximately 70 degrees. We will use Snell's law at the boundary where the total internal reflection occurs, and the equation and core times sine theta c. I would like using theta c equal n cladding times sine 90. Okay, and if sine theta c is the subject, we can arrange this formula. This equation becomes sine theta c equal n cladding times sine 90. N cladding is 1.48 times sine 90 is 1 over n core. N core is 1.59. Okay, according to this information with the index. And if we calculate it, result is 0.9308. So we can determine theta c equal arc sine or sine to the power minus 1 of 0.9308 equal 68.6 degrees or 69 degrees. Next question. A ray enters the optic fiber from the air through a core surface that is at 90 degrees to the axis of the fiber. So actually this is a cylinder and with the optic fiber inside and so on. Okay. The question, determine the largest angle of incidence I that this ray can have in the air for total internal reflection to occur at the core cladding boundary. Right. Uh, since light travels along this axis, the axis, the interval angle or R, it should be less than or equal to R, okay, equal 90 minus theta C, and it's equal 90 minus theta C. Just now we calculate already 68.6. This is close to 70, and it's equal 21.4 degrees. And after that, the next step, we will apply the Snell's law that n air times sine I is angle, equal n core times sine r. We are going to find sine I, and after that find I. So we need to rearrange this formula with sine I is the subject. So sine I equal n core times sine R is 1.59 times sine 21.4 over n air, and air is 1.00. Okay. And if you calculate, the result is 1.59 times 0.364 divided by 1. and it equals 0.5798. Now we're going to find I. I equal arc sine or sine to the power minus 1 of this number. Okay. 0.5798. And if you calculate, the result is 35.5 degrees. This is the largest angle of incidence of this one, of I. So the next question, describe what happens to rays of light with angles of incidence greater than I. I have provided my answer for this question, and as we continue for the next question, the attenuation per unit length in the core material is 5.5 decibel per kilometer. Estimate the length of the optic fiber that will reduce the brightness of light by a factor of 10 power 6. Attenuation, okay, attenuation equal 10 log 10 of 10 to the power 6. And we can rearrange this number, this logarithm number, based on logarithm system, that logarithm rule, that we can writing 10 times 6 in front, log 10 of 10. And this is 1. So it's going to be 60 because 10 times 6. So attenuation equal 60 and the unit is decibel. Okay. Now we will determine length. So length equals 60 over 5.5. And the result is 10.91 kilometers or 11 kilometers. Right. Let's continue to the next question. Distinguish between mass attenuation coefficients and linear attenuation coefficients as used in X-ray imaging. I have provided my answer for this question. Move to the next question. Monochromatic X radiations of photon energy E is used to image a bone fracture in a human leg. The mass attenuation coefficient for the bone is mu B, and the mass attenuation coefficient for the muscle around the bone is mu M. The graph shows the variations of mu B over mu M with ln E M E V, mega electron volt, this one. And this is the graph. Justify in electron volt the photon energy that is most suitable for imaging the bone fracture. Okay. Okay. According to the graph, this graph, when this is the axis of mu b over mu m, and the horizontally axis is the axis of ln e mega electron volt. If you look carefully, when mu b over mu m axis at 5.3 here, okay, so actually learn E mega electron volt from here, around 5.7 minus 5.6 or minus 5.8 or minus 5.9, but I will determine this is minus 5.7. Right, let's continue. When ln E over mega electron volt equal minus 4.7, we can writing this equation becomes E over mega electron volt equal e to the power minus 4 pound of minus 4.7. And based on the E rules, we can find that E over mega electron volt equal, if you calculate, 0.0091. So it means E equals 0.0091 mega electron volt. Okay. Now, we're going to convert into electron volt. Okay. Mega electron volt, this is 10 power 6, 10 to the power 6. So it means E equal 0.0091 times 10 to the power 6 electron volt. And it's going to be 9,100 electron volt. Next question. In a nuclear magnetic resonance NMR scanner, a patient is placed in a magnetic field formed by combining gradient and uniform fields. Outline. Why magnetic fields are used? I have provided my answer for this question. Okay. Let's continue. Outline how the gradient magnetic fields allow the locations of signal from the patient to be determined. Also, for these questions, I have provided my explanation. You may copy or maybe you can use your own explanation. Let's continue for the next question. 17. Outline the difference between open stellar clusters and globular stellar cluster. Open stellar clusters and globular stellar clusters. I provided my answer. There are three. Actually, you can find around 6 differences, but I just writing here, I just prepared 3 differences. Right, let's continue. Discuss how Cepheid variable stars are used for distance determination in astronomy. I have provided as well my explanation for this question. So I think this is clear. And the next question, galactic juice absorbs light, predict the effect that galactic juice has on the estimate of the distance to a Cepheid variable stars. I have provided my answer for this question. Next question, 18. Data for the main sequence star 10 letters T are provided. T, the sun, and L, the sun, refer to the temperature of the sun and the luminosity of the sun. Surface temperature of 10 letter T is 6.3 temperature of the sun. Luminosity of 10 letter T equal 100,000 luminosity of the sun. Calculate radius of 10 letter T over radius of the sun. This is the ratio. Okay, so we will using the Stefan-Boltzmann law. The Stefan-Boltzmann law is L equal 4 pi times R squared times sigma times T over 4. And we are going to change this term, okay? It's going to be like this. While this is, I will writing as the ratio of luminosity 10 letter T over luminosity sun equal, for this term, I would like to writing becomes R, or radius of 10 letter T over R of the sun squared, because this is squared. Okay, and then after that, for each part is T power 4 becomes T or temperature of 10, let's say, over temperature of the sun power 4. This is the value is 100,000 according to the information. Okay, and we're going to find this, and let's say over R of sun squared times this one. Uh, the value of the number is 6.3 or 4. So if this is the subject, this equation becomes R of 10, let's say, R of the sun squared equal 6.3 to the power 4, 100,000. 100,000 over 6.3 or 4, like this. So R10, let's say, over R of the sun equals square root. If you calculate this division, 100,000 over 6.3 over 4, the result is 63.47. And if you calculate this is 7.97 or 8.0. So let's continue. Show that the mass of 10 letter T is about 30 times the mass of the sun. Okay. We use the mass luminosity relation for main sequence stars. That is luminosity over luminosity of the sun, m over mass of the sun, power 3.5. So this is 100,000 over m equal m over m of sun to the power 3.5. So m over m the sun equal 100,000 to the power 1 over 3.5. And if you calculate, the result is 26.8 and it is 27. So based on this question is about 30 times. So you can approximate becomes 30 as well. Outline with reference to its mass, the likely final state of 10 letter T. I have provided my answer, my brief explanations about this question. Let's continue. Sorry, for number 19, the galaxy NGC 6251 is 350 million light years from Earth and has redshift of 0.025. So that the NGC 6251 data lead to an estimate for the Hubble constant of about 70 kilometers per second per megaparsecs. Okay, Hubble constant is H0, simply H0, right? The first step, I would like to convert distance to megaparsecs. Okay, megaparsecs, MPC, simply MPC. Right, 1 MPC equal 3.26 times 10 power 6 light years. So it means distance equal 350 times 10 power 6 light years over this number 3.26. to 6 times 10 power 6 light year. And the result is 107.4 megaparsec. Wow. And the second step is estimate the recessional velocity using redshift v equal z times c. C, I would like to using speed of light in kilometers. So it becomes 0.025 times 3 times 10 power 5 kilometers per second. This one, and it's going to be 7,500 kilometers per second. So one. And next, estimate H0 or Hubble constant. Hubble constant equal V over D. V is 1, 7,500 over 107.4, and the result is 69.9 kilometer per second per megaparsec. Approximately becomes 70 kilometers per second per megaparsec. Next question. Estimate using your answer to part A, the age of the universe in second. I would like to convert megaparsec becomes kilometers. 1 megaparsec equal 3.086 times 10 power 19 kilometers. Okay, so it means the age of university equal 1 over Hubble constant. So it's going to be, wait, I'm going to find H0 first. Okay. H0, implications of this information is 69.9 kilometer per second over 3.086 times 10 power 19, and it is 2.27 times 10 power minus 18, okay, per second. So it is 1 over 2.27 times 10 power minus 18 per second. So the result is 1 over 8. The result is 1 over 1 over 2. If you calculate 4.41 times 10 power 17. This is per second. It means becomes this unit becomes second, because 1 over second. So it also becomes second. And the next question, state the assumption you made in your estimate for part B1. I have provided this one. Number 20. The Jeans mass mg of an interstellar gas cloud is equal to CRT over m, where R is the radius of the gas cloud, T is the temperature of the gas cloud, m is the mass of the particles in the cloud, C is a constant that has the value 6.2 times 10 to the power minus 13 kilograms squared per meter per Kelvin. So I outline the significance of mg. I have provided my answer for this question. So a spherical gas cloud of radius 7 times 10 power 15 meters contains particles of mass 3.3 times 10 power minus 27 kilograms at a density of 5.0 times 10 power minus 19 kgm to the power minus 3 kilograms per meter cube. The mean temperature of the cloud is 10 K. Determine the stability of these clouds. Okay. Right. The first step, I would like to find volume of a sphere. Volume of a sphere is 4/3 times pi times r cubed. So 4/3 pi times 7.0 times 10 to the power 15, I mean, 15 cubed. And if you calculate, the result is 1.437 times 10 to the power 48 meter cube. After that, the next step, I would like to find mass actual or M actual. M actual equal rho times phi. Rho is 5.0 times 10 to the power minus 19, and phi is 1.437 times 10 to the power 48. And if you calculate, the result is 7.19 times 10 to the power 29 kg. And after that, Jean's mass, or mg. mg, based on the information, the formula is CRT over m, or 6.2 times 10 to the power minus 13 times 7.0 times 10 power 15 times 10. Okay, just multiply, over mass is 3.3, 10 to the power minus 27. One. And if you calculate, the result is 4.34 times 10 to the power 4 divided 3.3 times 10 to the power 27 minus 27, I mean. And the result is 1.32. This is minus 27. Okay. 1.32 times 10 power 31 kg. Since m actual, so once m actual less than mass, Jean's mass, okay, mass actual less than Jean's mass, the conclusion is the cloud is stable. Right. Next question. 21. Explain why the cosmological principle suggests that there can be no boundary to the universe. I have provided my answer for this question. B. The Planck Space Observatory revealed temperature fluctuations in the cosmic microwave background (CMB) radiation. Outline one consequence of this fluctuation. I have provided as well my answer for this question.